Hey there, this is Seth Schaefer from Team Just Cause Robotics. In today's video, we'll be going over my Just Cause Robotics motherboard, which is the main board used in my SSP kits, though also available for sale as a separate product that anyone can buy to use in their own robots. I'm going to talk about what this thing is for and how it works, and then I'm going to show how to solder it together to use in a robot or in an SSP kit. So, there are 4 options right now to purchase this board. Standard configuration, it'll come just like this with the screw switch mounted such that you turn it on and off by accessing the switch on the bottom. For that, you need a standard 3/32 inch hex key, which will be included with any SSP kit. If you get the screw on top, same kind of deal except the screw is accessed on top and the nut is on the bottom. Now, you'll notice there's a bunch of labels on the board, and if you're not tech savvy, this might not mean much to you, but I'll explain what everything does in detail in a minute. If you order it with an FS2A receiver, you'll get your FS2A receiver in a bag like this. It'll come with the receiver itself and an antenna, and then a bunch of right angle pins that you can safely ignore if you're going to solder this onto a motherboard. The FS2A receiver itself is just this tiny little guy with 12 pin holes in 3 rows of 4, and says, 4-channel FS2A on here because it's a 4-channel receiver. All you have to do when you buy a motherboard is solder on your XT30 connectors, like shown here. You put your male battery connector there, you put female connectors for Power 1, Power 2, and Power 3. You can connect any speed controllers or anything to all 3 of those, and it doesn't really matter which one you connect it to, though I would recommend that your highest power things be plugged into either Power 1 or Power 2 because they have the shortest electrical path from the battery. Your switch, you have a PCB switch through this screw, so you tighten the screw, it turns on, loosen the screw, turns off. Pretty straightforward there, same as on all of my other PD boards with a built-in screw switch. And then down here, this is very important and unique to the motherboard, there is an SB labeled solder bridge. So that's just this tiny little guy right down here. And to make it so that you actually get a full 8.4 volts out of this, you need to solder bridge that. So what does that actually do for you? Well, since I forgot to do this one, this is a good example. So let me connect my servo and my battery again. And right now, servo's kind of slow because it's only running at 5 volts. Set my soldering iron really low temp. There we go, got it that time pretty fast. Alright, so got a little solder bridge there that connects those 2 pads together. That connects an internal resistor to the BEC to let it know that it needs to operate at a higher voltage. So now, connect my battery and the servo, and it sounds totally different and moves way faster now, because it's now operating at a higher voltage. Alright, now let's get to what you probably came to this video for, how to set up your motherboard for first time use. So, first thing you have to do, and this is very important, is you're going to want to heat up a hot glue gun. So I'm just going to switch on my nice battery powered Ryobi hot glue gun here, so it takes about 3 minutes to heat up. Next, we are going to do the next very important thing, which is solder around the switch nut. Now, depending on which side yours is on, it might be on the bottom, but on my case, the nut is on the top, so the screw's through the bottom. So to do that, I've got my soldering iron here. I'm setting it to about 350 Celsius. The temperature is not that important for this. You just need it to be pretty hot so that you can get solder to flow to the huge pad that is underneath that nut. And we're just gonna touch the soldering iron in between the nut and the base of the board. Get a little bit of solder there, and then wait for it to heat up. And what you should see is that it starts to kind of naturally flow a bit in between the 2. So the press nut is pressed in, which creates a nice mechanical connection, but because the nut and the board aren't necessarily like perfectly flat and aligned, it doesn't necessarily make a great electrical connection. So you do need to do this step in order to ensure that you get the full current carrying capabilities from the switch and the board. And we're just adding a bit of solder and then kind of just slowly rotating around, making a nice solder bead 360 degrees around the nut We can, once it's hot enough, just feed solder in anywhere around it and it should flow nicely to where we want it. I would recommend using a fume extractor. I just didn't turn it on because it's noisy and I'm trying to talk in this video. That's pretty much what you should be seeing as far as solder joint connection there. So that's all we had to do on there. Next, these three are your female XT30U connectors. And this is the male XT30U because it has the pins that go into the holes on the female. Now, your male connector and your female connectors both need to go on here. You do one male connector for the battery and 3 female connectors for all your other devices. Now, if you look at the board, you'll notice there are some circular silver pads and some square silver pads, and you'll also see the outline kind of matches up with the orientation the connector needs to go in. So it's very important. This one in the bottom left here is kind of like upside down relative to all 3 other connections. So just keep that in mind when you pop them in. They need to be the correct orientation or you will definitely damage some of your speed controllers or whatever you plug into this by sending current through them in the reverse direction. So that's what you should be seeing here. What I'm gonna do is put my fingers over the connectors and then get my solder kind of close. And I'm just gonna get a little solder on the tip of my iron. And then I'm just gonna get enough that it kind of holds it in place on one of the connectors. Cool. Now we can flip it over and we can see if it's well aligned or not, and if it's not, then we have time to adjust it. Like you can see that one's a little crooked. So I'm just gonna push on that one and wet the solder again until it slides nicely into place. And maybe it's a little crooked, so we can correct that as well. This one looks pretty good. All right, next we're gonna do the other one. We're gonna fully solder it now. So again, kind of put the iron on and heat up both things and then just feed solder in. You don't need to try and get solder only on. Your goal is to get solder between the board and the connector, not to get solder only on the connector. You wanna make a connection between the two. Notice I still have my soldering iron pretty hot, which is why you need to work a little bit fast here. You don't need to go totally nuts here, but too much solder is always better than too little. Of course, you want to be careful not to bridge your connections between the two sides of one connector because that would short out your battery and it would be very bad. Alrighty. And this is what your solder joints should look like, more or less. Nice bead of solder all the way around all of those connection points. That definitely connects back to the board itself. Now sometimes you might find that you have solder built up on the thing but it didn't flow properly. Easiest way to deal with that is just hold your soldering iron for a few seconds until it melts again and flows properly and then move it away. Just like this. Once you've got enough solder on there, it will find the place that it needs to be. There we go, nice even connections there. Cool. So now we just have to do one more, just the battery connection. So again, it's upside down relative to the one below it. Very important to get this one correct, because if you get this one backwards, it probably blows up everything you plug into it. Except there is a protection diode right here that will prevent the BEC and your receiver from getting cooked, and the LED and stuff on this board. Everything on this board will be fine. Just anything you plug into these 3 connectors will get power sent to it backwards if you wire your battery backwards. So we're just gonna repeat exactly what we did before. Get a little solder on the tip of the iron, touch it here until we get the thing to stay in place. And now do the other side fully. Flip it and do the first side fully. Careful not to burn yourself when you're holding the connector, which I almost did. And that looks perfect to me. And now, I'm gonna do an optional step. If you're running higher voltage than 3S, sometimes you'll notice there's a lot of sparks, especially if you have large capacitors connected to your speed controllers that are plugged into this. The easiest way to prevent damaging the board, because there is a very thin layer of copper under the screw switch, is this is a very optional step. I wouldn't recommend doing this if you're just running the SSP kit or anything on 3S. But you just want to get a little dab of solder around the ring. You have to be very careful not to accidentally solder to the middle where the actual press nut is, because otherwise you'll be shorting the switch so it's always on. That's why I wouldn't recommend doing this unless you have to. But you're just going to build up a nice thin layer of solder around this ring. This works on all of my switches and all-in-one boards that use a screw switch and everything. The same trick works. You just build up this ring of solder so that if there are little sparks and arcs going between the screw and the board, it's not damaging the super thin layer of solder that's on the actual board or the thin layer of copper underneath it. It's more just wearing away a little bit of the solder that you can easily replenish. And by doing this, I was able to make it so that a switch that got damaged from arcing was back to life, and I switched it with on and off over 100 times without this wearing away. Now, after doing that step, I like to crank down on this like extra hard once to kind of squish that solder into the shape of the bottom of the screw. After that, you don't have to tighten it super hard. Just kind of like, I'd say about that tight is plenty for turning your robot on and keeping it on for a fight. It shouldn't be very hard to undo at the end of your fight. And you only have to undo it like a quarter turn to keep your robot off. Now, soldering the receiver on here can be a little bit tricky. There's two different ways to make this a lot easier for yourself. Way number one is as shown here. What I did here is I took a pair of flush cutters and I basically just snipped all of the pins really short on here so I could push the FS2A all the way flat against what this board is like the tips of these pins essentially, and that way there's easy access to the tops of the pins on the surface of the FS2A so you can solder them together. Another option would be if you just push the FS2A on a little bit, you could have it sticking out like that and then you can easily solder all the pins, but this is not as great because you've still got this big thing with some mass flopping around out here. So what I recommend doing is get a hot glue gun, and once it's nice and hot, you build up a bunch of hot glue, shove the FS2A on, and that will support it so it's not flopping around and prevent it from disconnecting due to any weirdness during a fight. I'm going to show, for the sake of example, the pin snapping method that I did on this board. So first I'm going to take the FS2A and I'm going to seat it properly all the way down, push it all the way so it's nice and flat against these little black plastic bits on the ends of the pins. And then I'm just going to cut the pins pretty much as short as I can. Might want to wear safety glasses for this actually, because those pins like to go flying. Kind of have to cut them from the back row forward. There we go. So that only takes like a minute. Now, I'm going to pull the FS2A off. Alright, now that my hot glue gun is actually hot enough, what we're going to do is make a big old dollop of hot glue here. Make sure not to get it on the pins, but just right there in general. And it's okay if it squishes out and spreads a little bit. Then we'll take the FS2A and make sure that the button is facing up and get all of those pins aligned. All 12 of them. Now push down until, again, it sits nice and flat, like so, and there's just some glue built up underneath it to support it so it doesn't flop around. Now we'll go in and solder all of the connections, and then we will have our board together ready to use. So this part is definitely the trickiest part of dealing with a FS2A on a motherboard, because you need to access the pins when they're kind of buried and you can only really reach over other pins. Now, the one thing that helps you out here is you don't actually have to make 12 solder connections, you really only need to make 6. You need these 4 on the top row to be connected, because those are the individual channels, but this entire row and this entire row, rows 2 and 3, are all already connected internally, so you really only need to do 1 of each of those rows. So first I'm going to get the 6 channels up top. Just keep the soldering iron in place, heat up the pin and connection, then dab a solder. And it's very important you not bridge any of these top ones to each other, because those are separate channel signals. And you also don't want to bridge the channels to any of the second row or third row pins, because that would short them directly to power or ground, so that wouldn't work very well. So that's really all you need to do, is solder 6 of the pins like so, 1 from this row, 1 from this row, and the 4 at the top row. For bonus points, I'm going to go ahead and do all of these, because as you saw, it's not that hard. It's just a little bit tricky if you don't have a good soldering iron that the tip, very tip, gets nice and hot. So it might be helpful to get a fresh soldering iron tip if you've got an old iron that you're using that you've used for a bunch of other projects, just to get this little bit of detail work done, but it's not so bad. Yeah, if you bridge 2 pins together on the bottom row or the middle row, like that's fine, like you can see here. That doesn't matter because those are already connected within the board, but just don't do that on the top row. Alright, I hope that that was a nice informative video for how you can solder together your motherboard for use in an SSP kit or other robot, and to get the FS2A on there as well. Everything I showed having to do with the FS2A, of course, is optional if you're not using one with this. Instead, you would simply plug your other receiver into these connector pins with jumper cables like I sell on my website that look like this. So you just get the white lining up with the channel pins and the black lining up with the ground, and then connect those to each channel of whatever receiver you'd like to use. And it would work basically the same. Just keep in mind, if your receiver is not compatible with a voltage higher than 5 volts, you should not bridge the SB bridge, and you will be running at 5 volts if you don't bridge this, which means any servos and other stuff will only be running on 5 volts as well, but you won't blow up your receiver.